So for the sake of recording, let me restart stating that today is Tuesday, April 21st, 4 a.m. GMT, and this is the first instance of the new timing for the Antrea community meeting. For this instance of the meeting, we will have Abhishek discussing with us about cluster network policies, network policy for Antrea. And Abhishek, the only thing that I don't know if the link that you shared over the public email is a public link or is it some form of restricted access document?
Oh, it should be publicly accessible, but I need to check whether I created with my corporate account.
Yeah, it's not. It only works if I log in with my
Yeah.
work account.
Okay.
I was with my private credentials. It wasn't opening it. I mean, we can sort it out this later.
Yeah, I will. Yeah, I will move it to a public link soon.
Okay.
But can you see my screen?
Yes, we can see your screen, and now I will shut up and I will let you discuss your proposal.
All right, perfect. Yeah. So basically, yeah, today I wanted to discuss the like some of the features and the functional aspect of cluster scope network policies. So what is the motivation behind this? It's basically that the Kubernetes upstream network policies are, I'm assuming most of us are aware of what they are, so I won't spend time in explaining the concepts of the network policy, but some of the things that about the network policies are that they are namespace scoped. So if you want to create um, some security policies for the entire Kubernetes cluster, you will have to essentially replicate that Kubernetes network policy in each and every namespace, and probably you might have an automation or something like that to perform that. But it's a tedious process. And the other thing is that if you want to add any new features to these network policies, you got to go to upstream, and it can be slow. So that can this adding something in Antrea project for now can speed that process up. Also, I mean, anything, the eventual idea would be that whatever works for the community or whatever works for our project, we should try to upstream that in the community and see if we can eventually get this in Kubernetes so that we can consume it directly instead of having CRDs. One of the other things that the Kubernetes network policies don't allow us to do is prioritize the policies. So essentially, the network policies are all set of whitelist rules. So they're all allow all. They're all allow rules, and you cannot group them or create a group of policies which have higher precedence over another group of policies. So those are a few things that led to this thinking about like creating a cluster scope network policy. So how we came across this is like basically some of the other CNIs provide some form of cluster scope policies. With experience at VMware also, we have security policies which we can apply at a larger scope. I looked through many Kubernetes upstream PRs and issues targeted towards this network policy field and or scope, and then there was some PM feedback for use cases. So the set of features that I have documented here is like collected from all these different avenues, and I have for now put them in two groups, like a P0 and P1, essentially saying that P0 is something that would be nice to have in the immediate first draft of the cluster network policies. P1 is something that maybe we can add later, but these are not set in stone. This is something that the community can give feedback to, and we can we can talk about it and see what makes more sense to be done earlier or what can be pushed on later. So just to go through these few features. Um, so today, the cluster, sorry, the network policies allow you to select workloads which are pods, and you for that purpose it gives you two kinds of selectors. One is pod selector, which can be put in the applied to and in the to and from rules. The other one is namespace selector, which can be put in the to and from ingress egress rules to select namespaces and effectively pods. Uh, Along with that, also the IP block is something that is supported by Kubernetes network policy. But one of the things that we thought that we could introduce with the cluster scope policy is like to select the ability to select other kinds of workloads, not just pods and namespaces. For example, nodes maybe something that can be interesting. I saw a few upstream issues around this. There was a discussion on having node selectors in the network policy. Even a couple of weeks ago, it was raised in the SIG network that we should come up with a V2 network policy version which might select nodes. So that's where that idea comes from. We can also select, perhaps provide a way to select external entities, something like a VM or a bare metal node, which is outside of your Kubernetes cluster. So you can then make your controller aware of these external entities, import them using some ways. We'll talk about that a little later, but we can perhaps, then the controller can be intelligent enough to derive the IP addresses and constantly monitor the change in the IP addresses of these particular CRDs, and then automatically apply rules based on that. So that's one of the things that we would introduce or would like to introduce. The other is today the selectors are all label selectors. There have been certain issues in Kubernetes, or feature requests in Kubernetes SIG network that they would like to select certain resources directly by name. So I put a comment up there, and then I thought maybe this is something that can work with the cluster scope network policy also, that the ability to select resources like namespaces directly by name instead of having label selectors. One valid concern is that if you are aware that certain labels with on your namespaces select you into certain restrictive network policies, you could just remove those labels, and then effectively your namespace is outside of that security policy, and then effectively you're allowing your namespace to access or bypass that security policy or the network policy. So unless you have admission controllers or some sort of ways to restrict label manipulation, but yeah, and also sometimes you don't want to expose certain namespaces directly, and there might be only one or two. So instead of going and labeling those namespaces, you directly want to put their names. So that's something that we can think about, directly, adding a field called match exact or something of that sort, where you can directly add names instead of just label selectors. Another thing that I mentioned was the prioritization of certain network policies. Like, since they're all whitelist, you're not able to set a precedence between two network policies. So one way to do that, and I know in Calico community they do it using tiering. And in VMware you have like categories or something like that. So here we could group these policies who we would want, or the admin wants to have higher precedence into a group called category, let's say, and then set a precedence, like certain higher order policies are evaluated first, and then they trickle down to the next category, and then to the next category, and then eventually to the default behavior. So we could do that. Perhaps we could also add logging on individual rule levels to, you know, to do some sort of incident logging. You could specify certain rules that, you know what, these rules I want to check whether if the packet traverses and is hit because, or is allowed or denied because of this particular rule, we would want that incident to be monitored or logged. So we could do that at GRUL level by adding a field. We could also support, I think I skipped one point, was like Kubernetes network policies allow only, sorry, have only one type of action, which is allow action. So we could also add a deny action, whereas you create rules which, you know, you explicitly deny traffic for ingress or egress on the applied tools. Similarly, we can also support a reject action, which could, instead of just dropping the packet right away, you probably send a response back to the requester. We can also be more granular in terms of setting priorities for different rules, you know, within the policy. I think soon I'll talk about the policy evaluation, how the rules. So that would be one proposal, and if anyone else has any comments on that, you can feel free to let me know, or you can comment on the doc. There are also other selectors that were requested upstream, and also, you know, in some like issues was like, you know, perhaps we could have services targeted instead of targeting pods, you know, because I guess one notion was that people in Kubernetes expose workloads via services, that concept. And so it's easy for them to remember the pod selectors, remember the services rather than pod selectors or the labels that were used. So that's one way to, you know, add more new selector. The other is like something called a DNS-based selector. I think in this case, the issue was that, or the request was that we can, in the to and from, we add some DNS selectors where you provide the DNS path, the name, and before applying the policy, you resolve that to, you know, some IP addresses, and then use those IP addresses in the to and from. And then it can be dynamically updated, so the policy is dynamically updated instead of, you know, hard coding the CIDRs using IP block. So this could be dynamic. So that was another request. So we could consider all of these features in the cluster scope policy. So let's talk about, so all of this can be achieved by creating a few set of CRDs in Antrea. So one such CRD that would help achieve this is a category CRD, which is a pretty straightforward, you know, by itself, it doesn't do anything. It just stores a priority, and user can create these categories and then specify a priority amongst themselves. So let's say we have an integer which a priority field where a lower number shows that it's a higher category, and no two categories can have like the same priority number. And then, you know, by default, as part of the Antrea deployment YAML, we could create three such categories by default: cat 0, cat 1, cat 1, cat 2, cat 3, so that users don't have to create themselves, you know, things work out of the box. And if they prefer to have more hierarchy and more categories, they're free to do so. We could also limit it to a cap of 10, because, you know, for all practical purposes, I guess more than 10 categories probably might not make sense. But, you know, most use cases should fit in within 3 to 10 categories. And one of the reasons why, you know, I thought we could set a limit to this category is hold on, let me just make sure that this is, yeah, I think this is fine. Anyway, so one of the other reasons why I thought we could put a limit is that, you know, when we think about implementing the category with OVS and tables, you know, each table has like about 65,000 priorities within it. So we would want to set a few like ranges of priorities for each of the category. So the more categories we add, the lesser the number of priorities are remaining. So maybe a limit of 10 might be good, but we can talk about it and then we can make this extensible or relax it as more we design and implement this. So yeah, go ahead.
Yeah, sorry to interrupt. Quick question. What is the advantage of making this like its own object as opposed to just like an integer value?
It's basically, if you have you could allow a user to create more categories. With the integer values, perhaps it might be hard to contain them or like validate them, but using categories, you could add some give it names. For example, you could have just say an environment category or a application category or something like that, and then give more description to a category. So I thought maybe it's better to have a separate object for it.
So it's a user experience basically.
Yeah. Like just kind of like decouple the category with like the policies. And also, if you want to change the order for a group of policies, you don't have to go in individual policies and change the numbers, and you can just do it, update the category, add a new category within it, or update the number there.
And Abhishek, within a category, well, how does the story work? Is there another order within the category as well, or are they all considered at the same level, and maybe you have the policies that drop, reject, always precede allow policies, or is there like another order within the category?
Yeah, so at the moment there is no other level of priority within the category. I will go to the next section, which actually kind of talks about how the policy enforcement will happen, including the category. So if there are no more questions on category, I'll just move to the next CRD, which is the cluster network policy CRD.
I think Steven had a question on the chat.
I just dropped I don't know if it's question, comment, and I'm not an expert here, but I know a little bit about it. Was wondering how your idea of getting policy down to the service or app level would overlap with Istio. Now, maybe you're assuming that not everybody even uses Istio, and that's a good reason to do this, but it strikes me that if your goal was to implement policy at service or app level, why wouldn't I use Service Mesh?
So this is, so I think your comment comes from the fact that we could consider more selective services. Is this the concern? So this is something complementing the Kubernetes network policy and not on the layer 7 level or not on the application level. This is still, we are talking L4.
Okay, got it. That makes sense.
Yeah, so the workloads are still pods, and some external entities, maybe like a bare metal node or a VM, in cloud or something.
Now, how would this fit in if you're talking about doing it down at VM level? Suppose you had something like VMs joining in with Kubernetes workloads, either mesh expansion, or there are ways to do it with Envoy and Contour. Would that be of some use here? Would there be some way to plug that into VMs?
Yeah, so for that, I think if we move further down, there's another CRD, which is an external entity CRD, which we can use to import these objects, like external objects like VMs or bare metal node, which is not part of the Kubernetes cluster. We can, and I'll talk about it when I come to the external entity CRD.
Okay, that sounds good.
So, so yeah, this is the cluster network policy CRD. So before we get into the individual fields of the policy spec, I just wanted to talk about the the evaluation or the policy enforcement. And I think this was where probably Salvatore, your question would be answered, and maybe you'll have some suggestions there. So this is how it would look like. Now, each of those cluster network policies will be referred, will have a reference to the category that it refers to. So that will then form a group of these policies within one category. So let's say we have 3 categories, or we have multiple categories, but let's say we have like 2 here, as shown cat 0, and then you have 1, 2, 3, n. And then we have like certain network policies which are associated with cat 0. So now they will be added into this particular group. Similarly, if you have a new cluster network policy which is referring cat n, it will go into this particular group. And now this is how the precedence order will take place. Now, as I mentioned, a cluster network policy may have allow or a deny rule. So let's talk about the allow rules first, because we are already aware of how Kubernetes handles network policies. So just a reminder, just to touch upon that, is that the Kubernetes network policies, when you have certain pod selector, a certain set of pods which are selected or targeted by a network policy for an allow rule, they are isolated from the rest of the cluster, and only traffic from the ingress and egress rules specified by that policy is allowed. Right? That's the behavior of allow rules. So the semantics in the cluster network policy for allow rules is similar. Basically, if you select certain pods or certain workloads in the applied to in the cluster network policy, they will be automatically isolated from the rest of the cluster, and only traffic allowed by the ingress egress rules in the cluster network policy will be allowed. So you can see the green boxes here. All of the allow rules will have the same priority within a particular category. And then we create a set of like the complementary isolation rules at a lower priority within the same category. I have an open question around this. I will ask at the end of the meeting so that I can get more feedback. So this is how the allow rules and the isolation rules will work. The deny rules work, pretty much as is. So there are no special semantics around the deny rules. Whatever is specified in the policy will be denied, and they will have higher precedence over the allow rules. So if you think about IP block selector, let's say you have a giant IP block and you want to allow that IP block to these workloads, but you want to carve out a slice which you don't want to allow from that IP block. So you can achieve that by specifying a deny rule for that carved out slice, and then specifying an allow rule for the IP block selector for the broader IP block. So then the deny will be first taken into effect. So then essentially making sure that traffic which was not supposed, was not intended, is dropped first. That's how the enforcement is I'm proposing. And then, once all the categories are evaluated, after that, the Kubernetes upstream network policies will be evaluated. So this is like, let's say it's like a category in itself, which has the lowest precedence, not exposed to user, because this is like an implementation specific, but detail. But here since there are no deny rules, you just have these allow rules and then the corresponding isolation rules to enforce the particular network policy semantics. Yes, go ahead. You're on mute.
How quickly those are enforced. Let's say I update the policy. What I'm thinking about is, suppose you have some security add-on that is monitoring for unusual behavior. The connection's been established and it's running, but my security monitor wants to alter it because it spotted some anomaly. Does your spec envision that that's mandatory to support that kind of thing, or is it undetermined, or are these policies enforced only when pods are dispatched or connections are made?
Oh no, I think they should be as soon as you apply a policy, and very similar to how we enforce network policies, the Kubernetes network policies. it should be similar. As soon as we apply this policy, it should enforce, like if it's a deny, then it should be denied.
Okay. Okay,
Um,
thanks.
I think, but the catch would be, I think only new connections will probably, because we
Yes.
probably have some established contract rules. So new connections from those pods will be, is that what you were talking about? I mean, were you trying to say the same thing, Antona?
Yeah,
I was wondering if an external entity could shut down or limit an existing connection, or if this would only be applied when the connection was first established. I mean, I could also see doing this for triage when, let's say I'm at an edge or on-prem location and I lost half my bandwidth and I want to alter the allocations between critical and less critical apps. Would what we're proposing here allow you to do that sort of thing?
Are you talking about bandwidth control, like, specifying some sort of bandwidth for some pod connections? Or?
Well, it could be I suppose, if you envision doing bandwidth, but maybe another form of triage is to actually cut people off entirely.
Okay, I see. So as far as I know, our implementation with OVS would lead to only new connections being following this, the policy enforcement. The existing connections will continue to be as is, but correct me if I'm wrong, Chan or Antonin, on this part.
Yeah, you're correct, because we use contract like other CNIs like Calico. It's not set in stone. I mean, if this was like a differentiating feature, we could, when a new network policy is applied, potentially like flush some contract rules that match the new network policy and basically reset those connections, and then it would be pretty much enforced right away.
Yeah, I'm just guessing that if ultimately we'd envision that perhaps this gets adopted as Kubernetes policy, I think the people on the architecture and steering committees would want something versatile enough that it doesn't apply to just one network implementation, but potentially others that may not have the same limitations.
Yeah,
so
it's actually pretty much the standard right now in all implementations of network policies, even the standard Kubernetes network policy object.
Yeah, so the thing about the network policy is that, at least in the SIG network, is that they are just a declaration. I mean, the implementation is CNI specific. There is no standard in-tree or in upstream CNI which enforces that out of the box. So that is like, it's up to the implementers.
Yeah,
Right.
and Abhishek, correct me if I'm wrong. There isn't even any specification on the desired behavior of the policy implementation. Is that correct?
Correct. Yeah. So even for the desired behavior, they actually kind of left it vague enough for like the default behavior of the cluster. It's up to the implementers or the admins to take care of. I mean, so it's just a specification. It's up to your own imagination.
Okay, thanks. I hope I'm not. This is my first time to one of these meetings, and tell me if I'm derailing a conversation by interjecting these kind of thoughts.
We do like it. We do like it a lot. Normally, our meetings are way more boring.
Yeah. Thanks for all the comments. So yeah, this is like the behavior, like overall policy enforcement model that is the proposal, but we can always have more discussion on this. Yeah, so moving forward, this is just a sample policy that I added in the doc to clarify things. Maybe we can just skip this part. And then we can perhaps take a look at the different fields. Yeah, here, I see that. I see your point, Anton. So the network policy, cluster network policy will be a cluster scoped policy, which would have like a spec which would like specify the desired behavior of this policy, and a status which essentially will store the feedback, like, whether things were realized, what kind of, realization was done before this network policy. So, and I know Chan has some proposals around that. Maybe we'll probably talk about it in next meeting or sooner. On the spec side, we have, like, this is where we'll add a category field, which will refer to the, yes, Antoinette, the name of the category. And this is how, and this is not an optional field. This is how a cluster policy will be tied to a category. Then there is an applied to field. This is similar to the spec.pod selector in the Kubernetes network policy. This is where the target, this is where the policy will be applied on. It's essentially not just pod selector, but it will have more than pod selector, maybe a namespace selector, unlike network policy. It can also select external entities, wherever in certain implementation, if we are able to apply policies on the external VMs, but if not, then they will be part of to and from. Then so that was applied to. Then there is, similar to the Kubernetes network policy, ingress and egress would be a set of ingress rules or egress rules. I don't think we need a policy types here, because presence of ingress rule would or presence of ingress would mean that the policy is of type ingress. Presence of egress would mean it's for egress, or presence of both would be in and out, or ingress egress both. The reason why I think Kubernetes network policy has the policy types is because I think they started off with ingress rules first, and then few releases down the line they decided to also add egress rules. Within the ingress rule, again, it's pretty similar to the network policy. We'll have a collection of ports to which this rule apply to. So which is pretty similar. The ports as the Kubernetes network policy, you'll have the protocols, supported protocols, and then port numbers and a name port. Perhaps in the port number, we could also introduce ranges of ports. I think that's something that can be a differentiating thing. I haven't added that in the doc, but we can add that later. But that's something that the Kubernetes network policy doesn't support. So that's something that we could add. In the ingress, the from would tell you from which is the source that is allowed, like what is the set of workloads that should become a source. Action, which is different, which is different from the Kubernetes network policy, that since we can do deny action, so this will specify the type of rule. And enable logging would then, if you set this to true, you would perform logging, incident logging for this rule or anything that hits this. Similarly for egress, except for from, it's two, and then this will form the destination part in the of the rule for the applied tools. Action, like I mentioned, allow and deny would be two actions that we start off with and then perhaps reject in the future, if it makes sense. The peer, this is where kind of we add the selectors. Where the IP block, now it's similar to the Kubernetes IP block, but the proposal that I have is that we do not have the except part of it, because you can achieve the same thing by doing a deny rule and an allow rule. I don't know if there is a need to add the accept slice if we can do it with deny, but if there is a use case that cannot be achieved with deny and Salvatore.
No, sorry, I just removed mute just in case I have to say something. I will first let you finish and then I'll talk.
Yeah, so this is where I have another open-ended question, is that whether there is a use case that cannot be solved by adding a deny and allow for the IP block, and whether we need to support except in the cluster scope policy. The pod selector is selecting pods via labels or by names. I don't think we can perhaps add validation to not support match name on pods, because nobody creates or remembers pods by name. It probably doesn't make sense for pod resources. Namespace, the other different thing is that when you select pod selector, in the Kubernetes network policy, it will select pods from that namespace. In this particular case, a pod selector by itself will select pods with those labels from all namespaces. So that will be the difference. Namespace selector, on the other hand, is again similar to what we have in upstream. Select namespaces based on the labels. Node selector is something that we can add, and we can select nodes based on labels or perhaps by name. One thing that and this is something that we can internally in the network in the controller convert the node into its internal IPs and then have an allow rule to the IP addresses. Using a node selector can perhaps solve use cases where you would want to protect certain host network pods or on certain ports and allow traffic or deny traffic on those things. So that's one use case that we see we can tackle with node selector. Then the open-ended question here is that, I mean, at the moment, I feel like perhaps we can add all the node IPs, all the IP addresses associated with the node in the allow, deny rule, whatever we create for. But yeah, it's again kind of if we have like some PM or any use case, like people who have use cases around this and they would want to select only one particular IP address or some other way, then maybe we can think about that. But at the moment, I can only think of like adding all the IP addresses of the node into the to from. The external entity selector, so as part of these set of CRDs, and there's another CRD called an external entity, which is used to import an external VM or something like that, which is outside of the Kubernetes cluster scope. And this selector is basically for those objects. So you can put labels on the CRD and then select those CRDs by using the external entity selector. So this forms like the network policy tier, and then if we decide to add more selectors, we can add it here in the future.
So I have a question here.
Yeah.
So even you have with node selector and external entity selector, I assume in your first version probably we don't support all of them, right?
Yeah. So this is where I've just left it open-ended, like what is more important, and we'll put it in P0 as a second first version.
Okay.
And so I'm just adding as much thing as we can in the spec.
Got it.
Yeah, but I guess at the end of the day, whatever we can achieve soon, and then we can start small and then incrementally add on top of it.
Got it. And for the policy rule, basically the priority is based on the order, right? So.
Yeah. So I think you probably missed this particular diagram. So here, essentially, just to recap, we create categories, and we group policies within a category, and each of the categories will always have higher precedence over Kubernetes network policy, network upstream policy, and within a category, all the policies which are referring, the deny rules will have high priority. The allow rules will have all the same priorities, and then the isolation for the allow rules can be created at a lower priority within that category. I had a open-ended question here is whether we want to add the isolation rules, the ones that I'm highlighting here.
Oh, so you're saying deny rules always have higher priority than allow rules?
Yes, because I think like when you create an allow rule, they implicitly isolate themselves. So having another deny rule for something like that below it probably might not make sense. And if we do want to order those deny rules, maybe we can do it in different categories to simplify the workflow. But is some use cases not targeted by this or cannot be achieved using this?
Okay, probably I will need some time to think about that. It's a little different from what I thought. I thought you will be able to define the priority flexibly. I mean.
Yeah, so that is I added that as a P1 kind of an item where we can add ability to set priority of rules at the rule level instead of working with the. So that is we could perhaps do that, but to maybe begin with, maybe we have them all share one priority above of the allow rules.
Okay.
But maybe we can offline you can give us feedback.
Sure.
So
Another one for the policy rule, do you think we can share one strat for both ingress and egress?
Okay. You mean not have these two separate?
Right. But again, we probably can discuss offline. I don't interrupt your talk.
Well, this is probably like maybe optimization of how to achieve the same thing.
Another thing that I'm thinking, if we assume, maybe I'm not sure it's the right case or not. If we assume the same interface can have multiple IP address, for example, even for ingress rule, do you want to specify which destination address for its rule?
You mean, is this for the node selector or for?
Even for pod.
Even for, so multiple pods with multiple interfaces?
Right. I'm not sure it's where the case or not.
We don't have any guarantee that the additional interfaces are managed by Antrea. So, I mean, I know from a specification perspective, it makes sense. From an implementation perspective, if the secondary interface is managed by some CNI that we don't even know how we configure the interface, do you know, Abhishek, if we can anyway configure a security policy for it?
I mean, if it's in the to and from, perhaps we can convert that into the IP address and then we can apply that. But if it's in applied to, then I don't think we need to handle the interface, right? Yes.
Yeah, I'm thinking that if you have a rule with both source and destination in the rule always, no matter it's ingress or egress, then you can support the case you have multiple IPs for your port, but you just want to apply the rule to one IP.
Yes.
For example, you have one IPv6, one IPv6, one IPv4. You just want to apply the rule to the IPv6. I'm not sure it's a wide case or not, but I think probably that's why
I think
some other format you have both source and destination.
I think if it's v4 versus v6, that probably can be addressed by adding a field into the rule, so that we then can target the correct interface or the correct interface or the IP address. But if it's in case of like a multis kind of a thing environment or multiple interfaces within on the pod, then it might probably be tricky to.
Okay.
Right.
I mean, my opinion, the problem is that the Kubernetes specification they try to stay independent of low-level details such as IP addresses, but maybe in that case you could use the network attachment CRD maybe as an additional selector to discriminate that which interfaces of a pod you want to apply the network policy to.
Yeah, I'm just talking from generic firewall rule perspective. You see, the firewall rule can be for node that have multiple IPs, and it can be a gateway node. That means IP probably doesn't belong to you, but you want to apply the rule to the traffic bypass user. Probably I'll think more. I don't really have an opinion. I just happen to look at the difference and think.
Yeah, I guess maybe we can think about it more. But perhaps maybe we can, I mean, we can start off somewhere and then add this and maybe keep the implementation as such that it's extensible.
Sure.
So it doesn't assume things. Yeah, so I think, so before I move on, I had this open-ended question here on this particular diagram is two questions around this. One was at the moment, the allow rules, the semantics to isolate these rules. I'm placing them within the same category, the default isolation. So for category 0, all of these isolation rules will be here. For n, it will be here. So effectively, what will happen, like these allow rules of like a lower priority will not take effect if they kind of, are not allowed by these isolation rules. Is that the expected behavior, or should we like bunch all the default isolation behavior at the lowest possible category?
That's a good point, Abhishek. And now explain to me how we move. I mean, the things that I don't understand here are how we move from one category to the other in evaluating policies. Because from what I gather, once you hit one category, then eventually you will hit also this isolation rule for that category where you will never jump to the other category. Or is there something that I'm misunderstanding?
So the isolation rules are only if like the allow rule, the selected applied to has an allow rule there. So if it has
Yeah.
an allow rule, then it will be isolated from the rest of the cluster. So if the packet is not destined to be applied to there, then it will flow to the next set of categories. So this is where I thought, exactly what your question is, that should we bunch these isolation rules at the bottom so that, if this is not allowed, then go to the next set of allow rules, deny rules, and then eventually flow to the default isolation rules.
This is actually the question I was meant to ask, a long time ago when you present this diagram. I mean, to me, for network policy, if you specify the allowed actions, you never sort of like explicitly say that the other traffic patterns apply to destinations should be sort of like denied. So essentially, if you have multiple rules which are selecting the same thing and they're in different categories, what I think this would possibly be more making sense if this means this allow is more of higher priority and this allow is of lower priority, but the higher priority doesn't mean the other traffic patterns will all be denied at this priority.
Okay,
So I think to answer Salvatore's question is when this falls to another diagram, this is happening when two network policy are selecting different apply tools. So if all the network policy in different categories are selecting the same apply tools, the highest category will cut them off entirely, basically, as of now.
Yeah, so this is where I had that open. That's why I wanted to spend some time on this particular thing, is what should be the expected behavior and what makes more sense in terms of use cases. So,
and maybe it's a bit easy to say, but I think maybe that it would actually help to have some actual use cases in the document, like kind of like a user story kind of thing, like, oh, I'm IT, I'm the cluster operator, so I want to really deny those things. And then you have like, oh, I'm a developer and I want to have those roles for my applications and how they can talk to each other. So maybe have an actual use case in the document would be useful.
Yeah, I'm just taking notes to take feedback for this. So yeah, I'll update that, add more stories. So yeah, so that's a valid ask. You can do that. So yeah, I'll leave these open-ended questions on the document as well, so that we can discuss more on that and try to come to a solution which makes more sense. So that was one. The other, I had another question, was that should we have a category which goes below the Kubernetes network policy? The reason why I think that might be useful is that it's something that we can use to dictate the default behavior of the cluster. Like when nothing works, let's say you want to have default deny on the cluster, and only after all the network policies or cluster policies are evaluated. So if we have that like bottom not exposed, bottom rule or category, perhaps we can add such rules there. Would that make sense?
But you mean that's only for default deny or default allow, or you can add more?
Yeah, or like the lowest of priority kind of rules, like how we have like some baseline security policies.
I saw that, but I just have a concern. I mean, this probably will make the cross-lateral behavior hard to understand. I mean, since people may not know your default rule.
Oh no, we don't add any default rules. We just provide a category where the user themselves can decide their behavior and add their, like we can document that, and anyone who wants to add such policies can add it to that. But we don't explicitly add any allow or deny rules in there. Just give
Okay.
the extensibility. That if it makes sense.
One more question, a little bit related to this. The cluster network policy is. Do you expect some airbag controls on the object? For instance, the user, which is the cluster administrator, of course, can read and write this network policy, but there could be cluster users like application owners that don't have right to modify cluster policies. Will they be allowed to see which are the currently enforced cluster policies, or do you think that these objects should be completely hidden from users which are not cluster administrators?
That's a good question. I mean, I was thinking that we will have our back out of the box for this these policies for the cluster admins, but the viewing is an interesting question. And for yeah, that's a good question. I did not think.
I mean, I think we can leave it open to the use case by use case. Specify.
Yeah, but what should be the default behavior? I mean, what would be?
I mean, for default, I think I believe that it should be okay for application owners to see at least which network policies are enforced. So, you know, if their traffic doesn't work, they are entitled to know why, I guess.
Okay. Yeah, I guess here is where like the user base can give a little more feedback. But yeah, that makes sense. We'll just add that note. So to add note regarding our back. Right. So I think we were at the rules because we did this, and then we just add a resource selector, which also includes along with the label selectors a way to match on the name. I'm going to skip the status part because I think Chan will probably have a more detailed talk around this sometime soon. So maybe we can. The only thing I wanted to specify is that unlike the Kubernetes network policy, we will have a status which can be used to denote the realization status, and perhaps I think in Chan's proposal we probably have a way for the controller to poll the agents or retrieve information from the agents about the realization status of each of those policies, and then the controller can then update the CRD with the status. But we can talk about this in detail maybe next week or later, perhaps over the talk as well. And then the final CRD that we would introduce is an external entity CRD. The spec kind of looks like this, where it's again another cluster scoped object used to import CRDs. Import workloads which are outside of Kubernetes cluster. So, for example, it could be like a bare metal node or some VMs outside. Perhaps this could be, there could be a higher level APIs which drive the creation of external entities. So think about services and endpoints. Like the endpoints map to the backend of services and are automatically created for every pods. So the user doesn't really create them. But you could also create an endpoint explicitly. So this is something similar on those lines. But to, so this is the spec, the target reference, kind of, if it's created by some controller, external, higher level abstractions, and it refers to those higher level abstractions, it could, insert some opaque data in here so that the controller or anyone who's watching on the Antrea controller can process it and have make use of that additional information. The endpoints would, kind of store the IP address and the name for the different endpoints associated with that entity. So you could think of like maybe a VM has multiple interfaces, and then you want to list them out here. The ports would be again like main ports on that entity, and the owner is something that recently added. It's probably, I think there was some cases where the Antrea controller can compute the applied to sources and groups and everything, and then it can disperse that information to the agents, which it does today, similar to what network policy, how the implementation works there. But you could have like another controller which probably takes these external entity information and then programs the rules. So for example, perhaps in a bare metal node, you have some component running there which is outside of Antrea, and then you can just listen on to the controller on this owner field, and then apply policies and create those security rules on that node. So this is one usage of it. Otherwise, the external entities can be translated into the IP addresses in the endpoints, using the endpoints, and then they can be automatically used in the to and from fields for the in the cluster network policy by the Antrea agents. So these are the set of CRDs that we propose, and I think we're very getting close to the hour. So I'm going to skip the YAML specs. I think we're getting close to finish. These are just human variable, some YAML specs, and some samples. I'll probably add more data as suggested by this. And then I also have a design section, but this is more implementation specific. Once we agree upon the top part, the feature, the functional aspect, then we can think about the design and implementation in more detail. And maybe we can take it on PRs also.
Hi, Abhishek. This is Srikar. So I have a question regarding these categories. So if, let's say, if there are two policies with the same category, how does the precedence work? Like, is it like order of addition? Or?
No. So at the moment, all the allowed rules will probably have the same priority. And since they are all whitelist rules, they will have the same priority, and it doesn't matter. Whichever matches, the rule that matches will be enforced. The deny rules will have higher priority, and deny rules of different policies will all share the same priority. And then they can, whichever is more specific will match. So the first they will be evaluated, and then the allowed rules. So this is, and then I think as per Jinjin's suggestion, I think he mentioned that perhaps we can have order among or between the rules of each of the policies, so then we can use those priority to that priority given in the rule to determine the order.
Okay.
And as an extension to that, we could also add ordering amongst policies. So within a particular category, we could define an order within policies. The only reason why I didn't add this in the first draft itself is because too much of ordering. It might become hard for people to understand. So,
okay, sure.
Hi, Abhishek.
Hey.
This is Young. So I have a quick question. So because we have all those categories and ordering of allow and deny rules here. I don't know if there's anything in, for example, the CNI space where they provide a sort of reverse lookup, that kind of mechanism for example, say if I want to know, can I do traffic from some pod selector to other pod selectors? I want to basically see if we hit the baseline policy or if this is allowed or rejected by some network policy or cluster network policy that is listed here. Did we consider, giving, a sort of service like this?
Yeah, I think that's orthogonal to this effort, but this was also raised in some SIG network meetings. Was that we need a way to, we could, or the SIG network can add some tools which could help in probing and let you know exactly whether this communication is allowed or not. I think the time when we received this was when we spoke about or kept about the testing framework, the network policy testing framework that we proposed in SIG network last month. That is when those guys wanted us to add this as part of that framework, where we give a sample input of policies or like some pods, and then the tool kind of tells the users whether this communication is allowed, or if not, then what kind of policies are blocking it in my deployment. So I think that's what you're alluding to, and so it's kind of orthogonal to the cluster network policy CID, but it's definitely something that we can extend as part of the network policy framework that we have. So perhaps we can add it in with that framework.
Okay, thanks.
All right. Unfortunately, we are at the end of the meeting, and I believe that our friends in Palo Alto would like to get some sleep, as it's getting late for them. Is there any final question for Abhishek?
If there are any offline questions, you can ask me on Slack, or you can comment on the doc, and I will port this doc to the like an open Google Doc.
Yeah, Abhishek, I only have a very 30-second open question for you. What should be the plan for delivering this in Antrea, in your opinion?
So perhaps we can start like, I'm already adding some design and implementation part of it. And as part in the issue that I opened for this, I have added some work items there. And as part of them, obviously, I think documentation and having end-to-end tests and unit testing is important. So I think I've already added certain work items in the issue. There'll be some agent side changes needed, some open flow changes, schema changes, addition of the CRDs and API structs, and modifying some of the internal structs that we have.
Okay, so thank you very much, and I'm going to stop the recording now. So thanks everyone for attending, and the recording will be shortly available as usual. And